Hi, and welcome back to your next video lesson for math class. We have been working with systems of linear equations for a few weeks now. If you recall, the first time we were working with systems, we were solving them by graphing them. We spent a few days doing that. Most recently, then, we moved on and we were solving systems of linear equations using a method called substitution. And we've spent 3 or 4 days on that strategy. And then now today, I'm going to introduce you to the third and final way that you can solve a system of linear equations. And that is called using a strategy known as elimination. So here's your learning target, that you will solve systems of equations using elimination. So this is what's different today. Still working with systems, still looking for that point where these two lines are going to cross each other, or the ordered pair that will solve both equations. And today I'm going to show you how to use elimination. This is a pretty important screen, definitely worth writing down or printing out, taking a screenshot and printing this, this page out. I think this is pretty valuable. This tells you what elimination is. Elimination is when you use addition or subtraction to solve a system of equations. So we're not graphing today. This is definitely going to be more on the algebra side of things, and there are some steps involved. Step 1 says that you need to write the system, or the two equations, so that the like terms are aligned. That means that the x terms are going to be lined up and the y terms are going to be lined up. And I think for the most part, step 1's pretty much going to be done for you on these problems that we do today in this lesson, and as well as the problems that you'll see on your assignment. Step 1's pretty much going to be done for you. In the future, at the high school level, perhaps not. You might have to rearrange your equations a little bit. But, you know, we're doing baby steps, and so we'll probably go ahead and take care of step 1 for you. Step 2, though, this is where you definitely have to get to work. Step 2 says add or subtract the equations, eliminating one of the variable terms. Okay, this is important. What you're going to see when you line these equations up, or when they are lined up for you, is that one of the variable terms, either the x's or the y's, are going to eliminate each other because one will be a positive and the other will be a negative, thereby making it temporarily kind of disappear. And you'll see what I mean here when we start working these things out. So what you'll be left with is the other variable term. So you will solve the equation for the rest, for that variable term. And then step 3 is take that solution that you got from step 2 and plug it back into one of the original equations, which will allow you to solve for the other variable, the one that you originally eliminated out from step 2. And then write your solution as an ordered pair. And I know that sounds really confusing, but I promise it's really not that bad. Here we go on to the next slide. Now here's an example that's been done for you. It looks terrible. It really isn't. We start with these two equations right here. This is our system. Disco. Looks like this. So you have to imagine that that's all you're seeing right now. We have a 4x plus 6y equals 32, and I have a 3x minus 6y equals 3. So there's my system. There's my two equations, and I've lined them up kind of like you would line up an addition problem, right? And if you're paying attention, I'm hoping that you see here that we have a plus 6y and a minus 6y. See those guys right there? Since they are opposites of one another, one is a positive 6y, one is a negative 6y, they essentially combine to make a 0. They temporarily kind of cancel each other out. They kind of go away just for a moment, so that when we combine these two equations, we're essentially going to add them together, just like you would an addition problem. The y terms cancel out, or actually what we say is they eliminate. The y terms eliminate each other because one is positive and one is negative. And what that leaves behind then for us to focus on are the x terms and then the constants over here on the right-hand side of the equation. So you can see then what I did. I'm going to erase this. I turned it into an addition problem. right? Because we're going to combine these equations. So I'm going to add here, I've got 4x plus 3x makes 7x. Plus 6y and minus 6y right here, that makes a 0. So we don't have anything in that space right there. That's blank. I'm going to leave it blank. And then I've got a 32 plus 3 more makes 35. So now I've taken my system of equations, and due to the elimination of the y terms, all I have left to solve is the part down here in red, where it says 7x equals 35. Divide by 7, divide by 7, and that's where we get our answer of x equals 5. Awesome. So if x equals 5, now you can take that answer and plug it into one of the original equations. Let's see, which one did I choose? I must have chosen the top equation. 4x plus 6y equals 32. So now you can see I'm taking the value of x being 5 and I'm substituting it in right there. So I've got 4 times 5, that's the 4x, plus 6y equals 32. 4 times 5 is 20, plus 6y is 32. You're going to subtract 20 on both sides. It cancels. So that's why 6y equals 12. Excuse me. You're going to divide by 6. And that cancels. Y is 2. Awesome. Now I know that x is 5 and y is 2. That's the solution. There it is as an ordered pair. Let's do some more. Solve using elimination. Okay, as you can see, step 1 has been done for you. The equations have been stacked and lined up so that the terms match up. And I like what I see. Do you see what terms are going to eliminate? I do. We're going to put these things together. A minus 4x and a positive 4x right here, that makes a 0. They eliminate. Okay? I've got a positive 2y and a positive 8y. That's going to make 10 y's. And I've got a negative 30 and a positive 20. That makes a negative 10 when I put them together. So again, I'm combining these equations. I'm adding them up just like you would like an elementary school addition problem. You add the columns together. So now I'm solving. Let's see, 10y equals negative 10. Divide by this 10 here, so it goes away. And I see now that y is negative 1. Great, there's half of my final answer. So if y equals negative 1, you can go back to your 2 original equations and pick one. Pick either one, doesn't matter. Y is negative 1. Let's do this guy. I've got 4x plus 8 parenthesis y, which is negative 1, equals 20. Okay, let's solve it. 4x, positive 8 times negative 1 makes negative 8. I need to add 8 to both sides. Now I've got 4x equals 28. Divide by that 4. X is 7. Guess what you've got now? You've got your solution. The ordered pair, or the solution for this system, x is 7 and y is negative 1. That means if you were to go back to your original equations and make x 7 and y negative 1, that would work for both of those equations. That is the solution for that system. Let's do another. This one's good. Looking for some elimination to happen here. Do you see what will eliminate? I think the y terms are going to eliminate. I see a plus 4y and a minus 4y. Oh yes, they are going to eliminate. So let's add our columns. A 3x plus another 3x makes 6x's. A positive 4y and a negative 4y, that makes our 0. So we really don't need anything there. In fact, I'm going to erase that so you don't get too confused. Bring down your equal sign. 22 plus 14 is 36. So now I have to solve 6x equals 36. Divide by 6. So that goes away. X is happy because he's alone. And now I know that X is 6. Great. Take that. Go back up to one of your original equations. Plug that 6 in for one of the X's. And solve. I'm going to use the first one. It doesn't really matter which one you use. So 3x, and x is 6, so that's where I substitute that in. Plus 4y equals 22. So 3 times 6 is 18. Oops. How about that? I need to move that 18 over. So subtract 18, right? We always do the opposite. 22 minus 18 is 4. Break that 4 off by dividing by 4. There it goes. Y is alone and he's happy. And the answer for y is 1. The answer for x was 6. So your ordered pair solution is the point 6, 1. Yay! Elimination is really not that difficult. Especially when, like in this example, the plus 4y and minus 4y automatically eliminate and become temporarily become a 0. They kind of get out of your way so that you can find the value of x. And once you have that value of x, you can go back and find the value of y. I like elimination personally. But, of course, they can always dial it up a notch and make it a little bit harder. This is the last example that I'm going to do. And, again, it's elimination, of course. But they dial it up just a touch here. I'm looking at these two equations, right, this system. And boy, oh boy, I mean, those x's aren't going to eliminate. And the y's, I don't see a positive 2y and a negative 2y. I need to do some work on this one to make those y's eliminate. Yes, yes, yes. One of those positive 2y's needs to become a negative 2y or a minus 2y. Now, it doesn't really matter which one you do. I'm going to focus on the top equation. And the way that you have to tackle a situation like this, where nothing's going to eliminate because they're both, in this case, they're both positive 2y's, and I want one of those guys to become a minus 2y, is that you just need to change the sign of every term in the equation you're changing. Does that make sense? Watch. You can multiply all parts of an equation by a negative 1. That's fair. As long as it goes all the way across the equation from left to right, you can do whatever you want to do to an equation. So in order to get this positive 2y to become a negative 2y, or to change his sign, you're going to multiply it by a negative 1. The shortcut way is just to say, change its sign. But if he changes his sign to become a minus 2y, then he has to change his sign and he has to change his sign. Everybody changes their sign. Everybody gets multiplied by a negative 1. So I'm going to alter or change this top equation so that it now reads like this. Negative 7x minus 2y equals negative 24. And you can do that as long as you're fair and everybody changes their sign in the whole equation. Knock yourself out. You can do that. Now the second equation does not have to change at all. He can stay positive 8x positive 2y equals positive 30. Now, do you see how doing that, and don't forget you're going to add these, means now that, look at those y terms. They're definitely going to eliminate each other. So, let's add our equations together. A negative 7x and a positive 8x right here makes positive 1x. A negative 2y and a positive 2y right there makes that 0y. So that's what eliminated. It goes away. Equals. Negative 24 and positive 30 makes positive 6. So now I know that 1x equals 6. X equals 6. And I think without doubt now you know where to go from here. If x equals 6, go back to your original equations. Pick one. Pick the top one. I'm going to take this and I'm going to plug them in there. Seven times 6 is that. Got to move that 42 over to the other side. Subtract 42. Running out of room. Hold on here. There we go. It's a little bit better. So now I've got 2y equals negative 18. Divide by 2. Y is negative 9. We found x to be 6. There is your solution, or your ordered pair. So, if you notice from your original system that no terms are going to eliminate each other because the signs aren't right, you can alter a whole equation, as we did in that top equation, if everybody in the equation changes their sign, which means you've really multiplied everything by a -1. And if you do that on the top equation, then we get our elimination to happen right there. All right? And there might be a few of those on your homework, not too many. I guess I shouldn't say homework. I should really say classwork. Because we will be working on this skill during class, you know this, over the next few days. And if you use your class time wisely, of course, there won't be an assignment to complete outside of my classroom. All right? So get your brains turned on. Let's finish up these systems. Let's finish strong. And we'll spend a few days on this, and then we'll have an assessment. I bet you can't wait. Thanks for watching.